All right, everybody's uncomfortable, so that means I'm doing my job right. Mr. Green, let's work this problem.
Okay.
Tell me how to do it. Let's do, wait, back up. Double angles, half angles, get rid of them right away, right? And sum of difference, get rid of them away. Do good algebra, change everything sine and cosine, do good algebra. Go, man.
Okay, so the first thing I did was I divided 3 from both sides.
You divided 3 from both sides? Okay, so let me ask you a question. If this was the question, would you be dividing both sides by 3?
No.
What would you do instead?
Cosine first.
You would do what?
So you do the cosine first, and so you arc cosine both sides, making the left arc cosine x, and then.
Wait. What are you trying to do? Try to divide both sides by x or something?
No, I'm trying to.
What did you do over here?
I mean.
Just tell me how you solve that problem. Don't totally forget this is over here.
Forgetting how to solve that problem.
Okay, everybody has those moments, right? We're like, oh God, my brain is down here going 100 miles an hour. Combs, can you tell us how you would solve this problem?
Put the 2 on the other side, so it's x plus 2.
Okay, I wouldn't do that either, but let's it's a step in the right direction.
And
Now what?
Subtract the x.
Okay, that's fair.
Then we're going to divide by 2.
Then we're going to divide by 2. All right, so we're going to do the same thing. Same thing over here, correct?
Yeah.
All right, Mr. Green, follow this along.
Okay, so you bring the 2 over, so it's cosine x plus 2. And then you divide the 3.
What do I do to get x's on one side?
You bring it over.
Don't I subtract x?
You arc sine?
I'm not even going to do that. Just write negative, subtract cosine x from both sides. Not going to work that hard.
Okay. Oh, so then you have 2 equals 2 cosine x.
Love it. Now what?
Then you divide the 2.
Divide both sides by 2. I get cosine x equals 1.
And then you arc cosine.
Where does cosine give me 1?
Well, cosine gives you 1 at 90 degrees, right? Or is that the wrong one? Oh, 0 degrees. Right.
0 degrees. So x equals 0 degrees. Now I check my instructions, right? If it's all real values, I got to write plus something, something, n. It's principal values. I'm going between 0 and 180, which this is okay. There'll only be one answer, which is nice. And then there's some other possibilities. They might say it's between 0 and 360, which means I got to go find the other one. In this case, though, it says principal values, so
you're good.
I'm good. It says express the answer in degrees. Have I done that?
Yeah.
Then we're good to go. So our answer is x equals 0 degrees. Congratulations, we just did our first trig algebra problem. What this whole chapter is about. All right, problem number 2 is waiting for you. X minus 1 equals 0. Here we go. What do you got for me, sir?
Add 1.
Add 1. So we got 2 sine squared x equals 1. Love it so far. Now what?
Divide by 2.
Divide by 2. I got sine squared x equals 1 over 2.
Square root both sides.
Square root both sides.
Square root of 1 over square root of 2.
Okay.
And that's just 1 over square root of 2.
That's just 1 over the square root of 2. I see a hand up. Yes, sir. Save us.
Wait, so when you're doing a square root of a fraction, you have to do
Square root of top and bottom is the easiest way to do it.
you can't do 1 divided by 2 and then square root of that.
Well, it's the same thing. It's just this is going to be something I can do without a calculator because it becomes 1 over square root of 2. How do I get that square root of 2 on the bottom? Square root of 2 over 2, and I get root 2 over 2, and that is one of the ones I know. 45 degrees. And I still marked off points for that. Plus or minus. Way back here, when we did the square root of both sides, this should have been plus or minus. And it's plus or minus, and this is plus or minus, 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 plus or minus. Therefore, my actual answer is x is 45 degrees and negative 45 degrees.
Do you have to write that, or can you write plus or minus negative 45?
You could do that. You could do that. Whee! Mr. Combs, okay?
Yeah.
All right. All right. Number 3 is waiting for you. Oh, the pain and suffering. There we go. And we have secant squared x plus tan x minus 1 equals 0. All right, first things first. We need double angles, half angles, you have to get rid of them. You see me?
What?
Not Cassidy, sorry. Do you see any? Miss Mancha?
For turning into cosine and sine?
No. Do you see any 2x's or x's or x plus x's or anything like that?
No.
No. So we're going to move past that step. Step 1, check, done. Do get algebra. You see any algebra you can do here?
No.
Combine like terms, you like, no, we don't do like that. Okay, next step. Turn everything into sine and cosine.
So I did 1 over cosine times 1 over cosine,
All right?
and then plus sine over cosine x.
I love
Minus
it.
1.
Minus 1 equals 0. All right. Now what?
And then would it be, well, I put it as like, oh no, I guess that does not work. Then, I don't know, I'm stuck there.
Okay, so do good algebra. We're back to doing good algebra. So there's a couple different things we could do. We have fractions, right, added?
Yeah.
Could we fix that? Do you want to fix that?
Yeah.
Okay, so what's the common denominator between these two functions?
Well, we could times one of them by cosine x, right?
That would be good. All right, so we got 1 over cosine squared x plus sine x cosine x over cosine squared x minus 1 equals 0. So far, so good.
Brendan, I have a question.
Yes.
Yeah.
Why didn't we start with good algebra?
What would be the good algebra you want to start with?
Move the 1 over
Move the 1 over. Why?
so that you'll positive 1 on the other side.
Why?
Well, so I did it very differently.
Okay.
You keep going. I'll
We're going to see how this goes.
Cool.
Yes,
Wait,
sir.
Rez,
I'm confused now. Why didn't we do like the crosses in the bottom, multiply the bottoms?
Because if I do that, I'm going to end up with a cosine cubed, and if I can avoid that, I want to avoid that.
So what did we do instead?
We multiply top and bottom. We notice that these are the same almost. I just need a cosine on this one. So she chose multiply top and bottom by cosine. And I'm with her. That's actually a good move.
Just multiply the right side by cosine.
Yeah, just top and bottom of this one by cosine. That makes cosine squared so they match, which is our goal. That's the reason why you multiply the bottoms to make them match. She's got a slightly more elegant approach, which I appreciate. It's a good actual approach. What?
Does the other way work?
It would, except you're going to have the cosine cube, it's going to give you a bigger headache for solving. Try not to get to cosine cube land if you can avoid it. Yes, ma'am. What do you got now?
could we do the negative 1 times cosine squared x over cosine squared x?
You're going to go ahead and add that to the max? Okay, let's do it. 1 plus sine x cosine x minus cosine squared x all over cosine squared x. Now, what did she do? She multiplied the bottoms, cross the tops. That gives her cosine squared over cosine squared. Everything's over cosine squared, so she put it over one big super fraction. All right, what are we gonna do?
Is there an identity with the sine x, cosine x?
Sine x, yeah, there is a double angle. I don't want to go there.
Oh, or I could
That's-
do, isn't 1 minus cosine squared x the sine squared x?
Yeah, I might not do that either because I got a cosine sine in here. Now hold on to that because we're gonna have to do that. I'm trying to pretend like I don't know I have to do that. Right
Okay,
now,
well
I got a cosine squared on the bottom. How do you get that off the
Yeah.
bottom?
Multiply?
Both sides by cosine squared x, right?
Yeah.
And I end up with 1 plus sine x cosine x minus cosine squared x equals 0. Is that okay with you?
Yeah.
All right.
And then now would we do the sine squared x?
Yes, we would, but you're going way too fast. We should pause a moment and go, this is desperation land, man. When we start doing that, it's because we're desperate. Turns out we're desperate, but for a moment you should look at this and go, is there anything else I can do besides that? Because if you start doing that early and you're wrong, you end up with a big mess on your hands. But you know that 1 minus cosine squared is sine squared, correct?
Yeah.
So let's go ahead and do that. See if you feel better about that, though. Crowd just got quiet. Tension is growing in the air. Now again, what'd she do? She said 1 minus cosine squared is sine squared. She's already desperate. She's throwing that in there just for the fun of it. All right, Ms. Manship, how do I solve something that's a squared and not a squared? Equals 0.
Should we just square root it?
Can you square root something with a plus in the middle? Do you remember doing that in the very first chapter? Isn't that a lovely experience for everyone?
We can, but we shouldn't.
You should know. Never, no. Not only can you, but you know. No, if it comes to that, you might as well quit. Huh? Yes. Oh no! Bye. Okay. Good luck, by the way. If I had x squared plus, say, x equals 0, what would I do?
Square root it?
You would square root it. Let me ask you a question. How did this make your life better?
Oh, no, never mind.
I would not square root that under even on a bet. Okay, so you're supposed to know that you have one of two options. I'm going to show you the more elegant option, which is I'm going to factor out an x. Right, we factor when we have a quadratic. And we set each of the factors equal to 0. Right?
Yeah.
So what can I factor out of both of these?
A sine x.
Sine x. And what does that leave behind?
Sine x plus cosine x.
Yeah, love it.
And then divide by sine x.
No dividing. Now we're going to set each of the factors equal to
0.
0.
Okay, so then sine x 0 would be 0.
0.
And the other one would be 1.
What?
Right? Because sine x and cosine x of 0 is 1.
If I put in a what? Whoa! Wait, hold on a second. I'm still working on what you're saying here. If I put a 1 in here, I get sine of 1 and cosine of 1. I don't know what that is even.
Oh.